Um,
Perfect.
so, hi everybody. I'm Sanchari Banerjee. I work as a senior AI applications architect at Blue Wave AI Labs. Here I work at the intersection of artificial intelligence, engineering, and the energy sector. So I work in a domain-specific role. And today we'll talk about some ways to break into AI and some practical skills, pathways, and some strategies and concepts regarding that. So moving on to the next slide, just to set the stage why this talk matters. So according to the WEF Future of Jobs 2025, 170 million new jobs are expected globally from AI by 2030. And uh, not all of these are just transitioning into automation, um, so to say. It is a combination of new jobs and also the the jobs that will get converted into automation with AI. So a lot of these jobs, about 50% of these jobs are going to be new jobs. So there is a net positive of jobs available in the market that's expected by 2030. Um, about 86% of employers have said that they expect that AI will transform their business by 2030. So, so these AI roles will span engineering, product, research, data, and domain specialization. The path in, however, can feel overwhelming because recently we have seen so many rapid tool releases. So everything changes within a couple of weeks, within a couple of months. There is a lot of jargon overload and unclear starting points. What really matters and how much is noise. What most people don't know is what skills actually matter versus what's hype. Um, so through this talk, I'll try to get a clear and honest roadmap grounded in real world practice. So here is what we'll cover in today's session, and we can broadly categorize it into six areas. The AI landscape, so what the roles, the teams, and what the field actually looks like. So, and some um, responsibilities associated with those roles. There are some common misconceptions that I'll talk about, and this will include what breaks people's momentum even before they start. I'll talk about the core skill stack, which will include programming, machine learning, generative AI, evaluation, and deployment. Some career pathways, so which will include ML engineer, data scientist, applied AI, etc. Building experience through projects, internships, open source, and some domain advantage that people can get by working in some specific areas. And ML fundamentals, which will be some short notes on a few important ML fundamentals and some popular concepts. So we'll get right in. So the field of AI today and the careers associated with it are really broader than most people think. So starting with, we have the ML engineer, and this is someone who can build, train, and deploy ML models into production systems. So if you think about it, this is really a natural extension of somebody already working in the field of software, or somebody already in line with software engineering. So this is a natural transition for them. A data scientist, so they can extract research insights, um, research statistical insights. They can build models and they can support business decisions. An applied AI engineer is somebody who would be able to integrate AI models into real world applications and workflows. A research engineer, so this is more of an in-depth research role. So this is somebody who would dive very deep into ML theory and will be able to develop novel algorithms and advances AI capabilities. The next is the AI product manager, and this person will be able to shape AI features, strategy, and user experience. Um, and then comes the domain AI specialist. So this is the person who will be able to apply AI to specific industries such as healthcare, energy, finance, etc. So these are broadly some AI careers that are available today. Here are some common misconceptions that I have myself had and I have heard around me. So the first is I need a PhD. So most AI jobs today don't require one, um, but what they do require is, however, strong engineering fundamentals and practical experience, and that's what matters the most for most of these roles. Some specialized labs with a lot of theoretical research going on, of course, do need um, a more in-depth knowledge and more hands-on research experience, and they do have their PhD requirement there. The next is the need to know every new model. And recently, we have seen very fast tool churn. However, the fundamentals, so linear algebra, for example, probability, these are the stable foundations that everything is built off of. So depth will always beat breadth here, and someone doesn't need to chase every new release, which happens so fast recently. Um, and then the third is projects alone are enough. So essentially, just building a model end to end might be considered enough. But what's also needed is to be able to um, communicate the results clearly, explain how the models have come to those decisions, and also to understand evaluation. So how do the models perform and any shortcomings that they have. The final one is a more recent one in today's scenario. So which is generative AI is just a fad and it's temporary, and real AI is just classical ML, machine learning. So uh, both of these matter and they do complement each other. Classical ML can be applied for structured data and reliability, and generative AI has recently taken up the stage, and very rightfully so, for language and reasoning tasks. So dismissing either will limit how much we can build with AI in today's world. Um, okay, so next I have four dimensions that drive success in the field of AI. The first one being technical foundation, so which includes Python, machine learning concepts. Um, it also includes the math behind it, linear algebra, probability, um, and then knowing about the data, deep learning basics, and the stable core that all AI work is built off of. The second one is practical implementation. So this includes projects. This can be personal projects or actual company-based project. It includes deployment, and it includes real problems. So essentially, this will be the ability to take an idea from notebook to something that people can actually use in production. The third is domain understanding. So this incorporates industry knowledge and context. So since AI is recently extended to many different fields and many different domains, understanding the problem space that is specific to that field, the constraints that are associated with that field, and the data and the stakeholders. All of these are important lessons that build a foundation for an AI engineer. The final one is communication and judgment. So since most of this work will involve a stakeholder and users, the ability to explain the results clearly, the application clearly, and evaluating the results honestly. This is something that really matters a lot in today's scenario, because there are so many different AI models, so many different companies um, who have some models ready for any and every task. But how do the people using it trust? So this is something that will help them gain trust on those models. The next is the core skill stack. And this is a multi-level stack. And for today's room, I'm assuming that basic programming and data is an assumed baseline. So that's the top layer. And it includes Python, SQL, Pandas, NumPy, Git, everything that you can think of. Next is machine learning fundamentals. It includes supervised learning, validation, metrics associated with certain tasks, overfitting and underfitting, feature engineering. Deep learning basics includes neural networks, um, we recently have LLMs and embeddings, transformers, and architecture intuition. Next is generative AI, which includes prompting, RAG systems, agents, and other fine tuning concepts. And then the core of all of this would be the evaluation, trust, and deployment that we just talked about. So this includes reliability, any societal bias, avoiding any societal bias, explainability, APIs, and monitoring. Okay, so the next is for people who know software. Here is what changes when we map these things into an AI scenario. So to start with, in software, we have deterministic outputs. So if there is the same input multiple times, the output will always be the same. Here, deterministic outputs get translated to non-deterministic outputs. So especially in the LLM scenario, we will have the same input but a different output. It also happens for predictive models, of course, small changes in the output each time. Prompt sensitivity, difference in temperature, which is essentially how much variability can you have in your answers, and the model drift. These will all determine how the outputs are. So a lot of unit tests that have traditionally been incorporated into traditional software fields that might fail. So we need other metrics and other ways to assign confidence scores to the outputs and ensure that the models remain within those bounds. Pass or fail correctness, and this now becomes a probabilistic evaluation. So in traditional software engineering, there is a right answer. Um, if an unit test passes, you know that it will follow those edge cases. However, here it gets more into the probabilistic space, and the evaluation needs more. So it needs metrics, it needs human review in certain cases, and statistical thinking to know that this really works. The next is bugs. So debugging in a software context is mostly related to code. And here in ML, the bugs can be upstream. So it can be anywhere upstream in the data. So a model that trains fine but performs badly in production, this might often have a data problem. It can be leakage, it can be skewed, it can have some label noise, some distribution shift that was overlooked. So it is important to look upstream to resolve bugs here. And then version control for code gets translated into model plus data versioning. So model behavior changes when data changes, and not just code. Not just the code version changes. So experiment tracking, versioning the data itself, and reproducibility are some concerns that need to be taken care of in this context. Feel free to stop me anytime and ask any questions. And the next slide here is a few fundamentals of ML that I thought are worth mentioning. Yeah, first, do you? Yeah.
Yeah, so in the last slide, you was talking about confidence score. So I also work in like AI engineering in energy, but like power energy, not in the nuclear energy. And I believe like nuclear energy is more sensitive to the data. So what's the best way to get those confidence score? Like I cannot ask the LLM to, hey, give me confidence. It will give me very high confidence score, and it may be like hallucinating and giving like, I am 100% confident. So uh, in your opinion, what is the best way to get those confidence scores, especially in a domain like yours, which is very sensitive to the data?
Right. So for us, we do two things. One is the traditional way of confidence score. So essentially, if the data that is being read, so maybe if it is an OCR application, if the data itself is unclear, that is like the most straightforward and traditional way to have the confidence scores on. So if it is hazy, we have a threshold, and then we say, okay, if it is below this threshold, don't have don't pass this off as the final result. But then another thing that really helps in especially the nuclear field is to be able to provide citations. So instead of just having a score, what we try to do is we try to locate the source of the information and really have a tight bound around it. So, for example, we can have, if it is, maybe it is a multi-GB a lot of gigabytes of data. But then if we can really pinpoint the source of where the information was extracted from, and maybe have a bounding box around that, that provides a citation. So this is one way we try to give. So this is not really a confidence score, but then it is a way to say that, okay, the model is confident that this such and such percentage of information is coming from this. So that's something that we do. Did that answer your question?
Yes, yeah, absolutely.
Okay. So the next is about ML fundamentals and what to sharpen. Um, so starting with data leakage. So this is one of the first silent killers of ML projects. Um, so what might happen is we are letting some future information into training, which won't be available while we are getting the predictions. So an example of this might be, I might be looking at some user churn, the user churn predictions based data. And if I'm using maybe the number of days that the user has logged into, and if that number of days is logged after the actual user churn data is pulled, in that case, I'm using something that I won't be getting when I'm predicting it. So this is so this will lead to data leakage. So this also happens in the field of energy. So we have certain sensor outputs which won't be available while we need the predictions. So we can't include those and just say that, okay, if the predictions look great with these inputs, it will always look good. Choosing the right metrics. So only accuracy is almost never the right metric. So especially in cases where there is unbalanced targets. So for example, in healthcare or fraud detection, the percentage of false positives can maybe just 2%. And if the model is always predicting just yes, it will still be 98% accurate. But if it is failing those 2% of cases, then it's an useless model. So in that case, we need to incorporate other metrics: precision, recall, F1 scores, AUC. These are all trade-offs, and these are based off of engineering judgment, based on um, how important false negatives are. The third one is overfitting versus underfitting. So the model works on training data, but it fails on new data. So the solution is not always to incorporate new data. It might involve other things. It might be actually diagnosing the problem, adding different features that will drive the predictions better. So this is something that also causes the models to fail. Um, here is a slide about model evaluation and trust. So like we already discussed, accuracy is not the only success metric, especially in unbalanced cases. So we have a few issues that we see from time and again. Hallucination is one of them. So LLMs generate confident and real sounding false data. So detection and mitigation of these are active research areas currently. Bias and fairness. So models can encode and they amplify societal biases. So before deployment, it is essential to audit these edge cases. Explainability. So are we able to explain why the model made a decision? This is really critical for regulatory industries and stakeholder trust, especially. So, for example, in my industry, um, if I'm able to get some engineering insights that the actual stakeholder can use, will help them get trust in the models. And Shapely values, which is a game theory based approach, is one of them, which we use to drive explainability. And there are many other such approaches. Robustness. So does the performance degrade on slightly different inputs? So is it a graceful degradation or is it catastrophical? So that's something that is needed to understand, because especially in predictive environments, the new data can fall outside the expected distribution. So in that case, we want to have a graceful degradation of the model instead of it getting some catastrophic results. Human review. So this is an important one. Instead of using AI as the final decision maker, um, it should always have humans in the loop, and it should always just be used as a decision support tool and not the um, final decision maker. Monitoring. So production models will drift over time with changes. There is no question about it. It might take longer for certain cases than others, but it will drift. So it is necessary to set up metrics, alerts, and different processes for ongoing evaluation. So it can include uncertainty bounds, anything that is relevant to cases, but this should be incorporated um, from the very beginning instead of having it incorporated later. Okay, so this table um, is just about a few careers and what they do and some core skills. So we already spoke a little bit about this. So ML engineer is the is a very natural transition for software engineers moving into AI. Um, I will just talk about a couple of these. So a domain AI specialist. So this is somebody who can apply AI to a specific industry or a problem area. So for example, somebody um, who is trained in civil engineering, for example, if they are able to um, build something which can detect anomalies in maybe um, a bridge design or something like that. So in that case, they will be a very good fit for a civil engineering industry and AI incorporated into it. So the next is how someone can build relevant experience. So it can be through work projects, applying AI to your current job, any small automation. And this is and this can be done for jobs which are in primarily AI. So just a small automation task or analysis projects to demonstrate initiative and domain knowledge. Portfolio projects, so end-to-end projects that you care about. It can solve some real problems. And this can be on GitHub for visibility. Internships, this is a really high signal experience, targeting AI teams at companies where your domain knowledge gives you an edge. Open source, contributing to ML tools, writing documentation, reviewing any issues. This really builds visibility, and within the community, it helps gain visibility. Kaggle competitions. So not just to get on the top of the leaderboard, but if if someone focuses on learning from the top kernels, this can build ML intuition pretty quickly. And some domain applications. This is the last one: building AI tools for your own industry, hospital scheduling, something as small as energy forecasting, some legal summarization. Um, so this is a short interview preparation roadmap, starting with coding, which is of very high need in engineering roles, Python fluency, data structures, algorithms, pandas, and NumPy operations. Um, High priority in data scientist roles, SQL and data, window functions, data cleaning, any aggregations. ML fundamentals are universal in every AI role. The depth or the mathematical um, I mean, the need to prove everything mathematically, that varies from role to role. So, for example, bias, variance trade-off, evaluation metrics, how to select models, regularization. These are all ML fundamentals that are good to know. LLM and generative AI concepts. This is rising rapidly right now across roles. Knowledge about transformers, RAG, prompting, agent patterns, evaluation. And then system design is an important one, especially for senior roles. But however, these are also very popular currently for mid-senior roles. ML pipeline design, data collection, how will you serve a model, monitoring any issues that come up in the server area. And then the last one is behavioral and the star-based project description. This is for all roles. So here is a slide where someone's domain expertise can be an advantage. So, for example, in healthcare, someone who has experience of clinical notes, imaging analysis, patient risk stratification, etc., they can they have the background needed to implement AI in this. Finance includes fraud detection, risk modeling, NLP on filings, forecasting. Energy has predictive maintenance, anomaly detection, load forecasting, compliance. Same for manufacturing, education, cybersecurity, and other fields. So for these fields, this will provide the basis of everything. And then on top of that, ML theory and practice can uh, build a good product. This is a list of some advice that I wish I knew earlier. So this is kind of from my personal perspective. So the first one is to master fundamentals before chasing tools. So the frameworks change every year. However, uh, the math behind it or the fundamentals behind it, linear algebra, probability, and clean code, that doesn't change. So depth and foundations will let you adapt to anything that might come up. Building things that are actually useful. So um, the best projects will be able to solve a real problem for a real person or a real industry, essentially. So being useful will beat an impressive sounding project name. Learning to evaluate before you learn to build. So initially, in my early days, I also underinvested in evaluation, I would say, and then I had to change my approach later on, and that needs a lot of rework, which isn't necessary if it's incorporated from the get go. So if you can't measure it and if you can't improve it, then it can't be trusted. So incorporating evaluation metrics early on is a good practice to have. Being able to communicate clearly, especially about the limitations. So engineers that the people trust most will be able to explain where the models might fail and where it does well. So, so that should be incorporated into practice. And then the last one might be a little controversial, but to not let perfection stop from stop you from shipping the product. So essentially, if it is currently meeting the needs of some of the user, it can be shipped and then it can be iterated upon with feedback and made better. So this is the final slide. A few key takeaways. So AI careers are broad. There is no single path in, and someone's background will shape the unique advantage that they will have in this field in the long term. The next is that technical fundamentals matter a lot, and they matter the most actually. So ML concepts, evaluation metrics, um, data skills, and Python. Real world problem solving matters. So to be able to deploy things, so end to end, a knowledge of end to end deployment, that really helps. Um, Measuring them and to be able to explain the limits honestly. Uh, Domain expertise is valuable. So with more AI adoption, industries need people who understand both AI and context, and this is especially valuable in startups and scale up industries. Trustworthy and responsible AI is the core. So evaluation, really good evaluation, bias awareness, and human oversight, these are not optional in today's world. Yeah, so with that, I'm at the end of the presentation. Any questions from anybody?
Many questions, Hina, Kostav, Nele.
Yeah, I have one. Yeah. So yeah, it was a fantastic presentation. First of all, like the slides were very good. I like the slides. So for I had one question about like you talked about like ML engineer, data scientist, and different roles which may sound similar but are actually a little bit different. So I also get asked that question very much like, okay, I am new to this field, I am into this field, then which one should I target for? So do you have an answer for that? Like how do you answer that type of question? This is kind of like a meta question, but yeah, I think if you have it, Yes, yeah. Or anybody else in the room if they have any idea.
Yeah, I think, yeah, I'll just go first. So I think it, like my answer would depend on two things, like what their background is and what they're interested to do eventually. So, for example, maybe somebody's coming from a very domain specific civil engineering background. But then if they really want to transition into a very research scientist or research engineer role, which really needs a very strong CS or math based research background, um, in that case, they will have to build that research appetite to a PhD maybe. But then if they are trying to look at an applied engineer role, that can be transitioned into, I think, more easily.
Yeah, that sounds good. Yeah, anybody else?
Yeah. That's another very important question, Costa, which you raised. So I would just add one thing that, it all depends on who the person is, what is the background, and what is the individual goal of the person. But one thing is always common, that the employers are always looking for people who have shipped something. If you have shipped something, production systems is always more, preferred than someone who's having like a lot of certifications. Tell the employer that, okay, this person is good with this particular stack. But I've seen always a bias towards people who have shipped something. They always get, it's always a higher chance to get interviews, and once you get interviews, you again increase your probability to obviously clear the job, to clear the interview. And even yesterday, I was in a meeting, and like I spoke to different employers, and I asked them, okay, what do you look for candidates when they come to you? So one of them instantly said that, okay, I need someone who can work with agentic AI. Now there has been some change in the way the hiring has been happening. Everyone says in fundamentals matter, to which I agree, but practically, they're saying that, okay, do you know Google Stack? Do you know ADK? If you want to build agentic systems, have you built something with RAG? Do you know the fundamentals of RAG? I mean, obviously, it's the baseline has shifted. Primarily, the interviews initially were more focused on testing your ML depth and deep learning depth, but now they expect that these things, right? And it has moved beyond that to these agentic systems. Can you think like from the system design perspective? So something which you would expect naturally from a senior person, now at least at mid level they're asking that. So the bar has been more tough now these days. What do you guys think?
Yeah, definitely. Especially with more and more people wanting to get in. I think that's one of the primary reasons, of
Yeah.
course, that the bar is now higher.
And the AI has made a lot of change in the way people are hiring. Like according to one of the report of Cengage is one of the major players like Pearson. So according to that report, 15% there has been a drop of 15% in the employment, like at least the entry level, and the amount of applications that are coming in has increased by 30%. Why? Because now people are using AI to automate job applications even if they are not qualified for that. So
Mm.
this makes the HR's life really difficult, but at the same time, it also screws up the candidate because he is or she is just going by the bulk number, and it's always a debate that, okay, should you be very selective in your applications, or should you just go by number game? That, okay, I'm going to apply to 1,000 jobs, maybe I'll get 50 interviews, and then the funnel works like that. But it's tricky, it's any insights from the anyone from the panel?
I would like to add one more point to that. Like, yeah, what I say to people is like, okay, you have to try and find a niche domain which is not export. Like recently, I think I mentioned it to few folks. Like I was in Alaska for a conference, and the domain of that conference was environmental permitting. Like if you are building a road, then do you need a permit? So that was the domain, and they are very like AI is very new to them. We were bringing some AI stuff and some data set based on that, and they are very skeptical on that. So if somebody wants to apply some AI engineering, so I would say, okay, find domain like this where there is less, like less people have worked on that, and then go into that. Like now, starting with computer science, and that is very like there are a lot of people already doing that. You are very back in the race. So yeah, this is one thing which I suggest people.
Yeah.
Yeah,
And
I
like,
think
yeah.
Sajidan, yeah, sorry. Sajid and Kaustav both raised like really good points. So one thing you mentioned is that like should you like focus on the numbers game or like should you be very selective in your job search? I think that juniors at least they have to play the numbers game. But if you are a mid-level senior and what Costa was saying, like if you are specialized in your role, then you have the option to like have a very selective job search. But I think like juniors now have an opportunity to apply for roles where they might have not been like qualified enough since like prepping up with AI is like really easy now. Like someone who has gone through the interview process recently, I realized that using like AI tools, you can ramp up your interview process and ramp up your skills like really quickly. So I think that for juniors at least, of course, like there's like talks of job losses, but I think like at least in the interview process, like you can have more opportunities, but not sure like if you're gonna get the interviews. But yeah, you can definitely apply to a lot more roles now.
That's a great advice, Neela, because getting an interview itself is like a full-time job now. It is, the system is so broken, not complaining, but that's a fact. But again, anyone who would be watching the session later, they would seriously have strong takeaways from the session. I was actually noting down what Sanchari was talking about, like the fundamentals, the more emphasis on fundamentals rather than going by those fancy tools, and then focusing on solving some real problem, and focusing more on shipping something rather than perfectionizing whatever you've done. So I'm sure anyone who's watching will get some real insights about where they should focus on. So, and again, of course, point of view by both Nilesh and Costa. And I just wanted to add one more thing to, just, you can just chime in, that recently we've also heard that there has been a growing uh, criticism of the data centers around the length and breadth of the country. So people are saying that we are losing jobs. So how do you interpret this? Like, anyone can speak up. I'm sorry to put you on spot, but uh,
I can go ahead. I have been discussing this for some time with our folks.
excellent.
So yeah, so there have been a lot of talk about the jobs and about the energy usage because this data center use lot of energy. So, but the idea is like what I have hearing people like these data centers are being placed in a region where there are less jobs or less opportunities, or in remote town where there are lesser opportunities. So if people out there who may not be that trained in AI, they can take other jobs in data center. There are thousands of jobs like network maintenance, then those hardware maintenance. So that would be actually beneficial for them. And I would say, yeah, there is ups and there is like trade-off for everything. Like you give some and you lose some. But I would say, in fact, it may take some jobs, but in the long run, it will create more jobs. But the job distribution will be different. Like previously, it was either highly skilled or no skill. These people got job, but now it will be like okay, highly skilled people will get some job, some medium skill like who has some hardware engineering experience, or somebody who is like zero skill, just like labor, masonry, that kind of not zero skill, but that's what the correct way to say. Lesser skill, they will also get some jobs. So I would say we are not losing jobs in the long term. The job market just getting redistributed. That's my take. Yeah, it could be hot take, but
That's completely fine. I mean, definitely there has been job losses, but then there has been people predict, according to different reports, that there would be a net gain in the jobs. And it happens every time. When internet was launched, there was criticism against the internet, that okay, people will stop going to the library now because they can just pull up the information from the internet. But internet has its own pros and cons, and likely AI will also have its pros and cons. And we have seen that agents have been in the past deleted the entire databases of the company. So those kind of episodes have happened, and there are a lot different criticisms too. But then again, it depends on the unique company, how they want to use it, and how people take it and how they respond to it, either by upskilling or by criticizing. Again, it's an open question. There's no right or wrong answer. But would anyone like to add anything before we wrap up today's session? I know we are past 8. Okay. Okay, everyone is good. Yeah. So thank you, Sanchari, and all the panelists for participating here, for your time. And it was indeed a very good session. We do conduct these sessions at IEEE, and it's always a pleasure talking to intelligent people like all of you here. So thank you again for coming, and we'll see you next time.
Thank you. Bye.
Thank
Thank
you.
you.